Hello everyone, welcome to the lecture series on measure theoretic probability. So, throughout this lecture series, we will learn the basis of probability theory, and learning the toolbox of this theory, we will be able to apply in our field of interest. So, we will be interested to model random experiment. What do we mean by a random experiment? So, this is an experiment whose outcome is unknown. And for you to model this kind of experiment, you need to know the sample space involved. Okay, so this word is kind of scientific for which you don't know the meaning. So what do we mean by sample space? So the sample space is the set or collection of all possible outcomes of a random experiment. We denote that by omega. So we can actually consider some examples of what random experiment. Example, when you toss a fair die, you don't know whether you get a head or what, a tail. So in order to model this kind of this random experiment, the sample space involved is what? Head and tail, where H denotes what? The head, and T denotes what? The tail. So these are the possible outcomes from what? Tossing what? A fair coin. Another example is, if we roll a fair die, we don't know whether we get 1, 2, 3, 4, 5, or 6. So if we're able to collect all these outcomes together, we get what? A sample space to model this kind of what? Random experiment. So if you have any element that belongs to this sample space, we call it what? The sample what? Point of what? The sample space. Another interesting thing we would like to know is events, because event will be something key in our study. What do we mean by an event? So whenever you have a random experiment, we know what? We have to know the sample space involved. And the event is the subset of what? The sample space. So from our first example, tossing a fair die, a fair coin, we had the sample space to what? Head and tail. So if you pick the set of head and the set of tail, then we have what? An event in this sample what? Space. The second example too, we roll a fair die, we have the sample space 1 through 6. The event could be a set of 1, a set of 2, a set of 3, or a set of what? 1, 2, 3 in that. So these are what? Some examples of what? Events in the sample space. Next, we will be interested. We want to assign probabilities to some or all of what? These events. Then it is necessary to work within a class of subsets of the sample space. So then we study what we call fields and sigma fields. So these are the field and sigma field. What do you mean by a field and a sigma field? So first of all, let us consider an arbitrary sample space and non-empty one. So let us consider an arbitrary non-empty sample non-empty space. That's omega. So we say that a class F of subsets of omega is called a field if it satisfies these conditions. So before we call F a field, then it needs to satisfy these conditions. 1, we have to have the whole space belonging to what? The field. 2, for any element that belongs to the field, its complement should also what? Belongs to the field. So F is closed under complementation. 2, for any finite element, or for any finite elements of F, or for any finite subsets of omega, we have A1, A2 through AN that belongs to F, then the union should also belong to F. So a question we want to ask ourselves, we want to ask ourselves is that, do we have the sample space belonging to F? That's a question we want to actually find an answer to. And in our next lecture, we will find the answer to this. So these are the conditions for which F needs to satisfy to be able to call what? A field. Now, what do you mean by a sigma field? So a class F of subsets of omega is a sigma field. If it is a field, this implies that these conditions needs to be satisfied. That's condition 1 through 3 needs to be what? Satisfied. And in addition, it is also closed under the formation of countable unions. So this implies that if you pick A1, A2 to infinity, that belongs to F, then 3 star needs to also what? Needs to be what? Satisfied. And the union of AK from 1 to infinity should belong to F. So another question we want to ask ourselves is that, is it true that 3 star, this one, imply what? 3? Imply this? Implies this? Okay, there's a question we want to actually find an answer to. So today, we've gotten to know about what we mean by a random experiment, the sample space, some kind of examples of random experiments and how we model that, events, and sigma fails and fails, and we know the conditions for which a class F to satisfy to be called what? A field or a sigma field. Thank you very much. In our next lecture, we will actually delve deeper and know what comes afterwards. But remember, we have 2 questions to solve. First of all, does the empty set belongs to F, for F being what? A field? And the second question is it true that 3 star implies 3? Alright, have a good day and see you next time.